where we left off last week. Okay, cool. So coefficient of variation, and I think there's very little in your books around that, but it does sneak into assignments and into exams. So I think when you see coefficient of variation, please look out for that, and definitely it will be one of the questions in the exam. And how we calculate coefficient of variation is also sometimes, I don't even think it is in the study guide, but it's definitely in the textbook and in the notes that I've shared. So it is your standard deviation divided by your mean, and then you multiply that by 100 to get 100%, to get a percentage point. Okay, so that is how we work out the coefficient of variation. So sometimes they can give you, say, the standard deviation, because if you now look at this, we basically don't have that or that. So we need to calculate this. And that is where I again usually will use my Excel spreadsheet. And I think that was actually the numbers that is in there, but let's just quickly put it in here. So what was it? 100, 104, 110, 111, 112. So remember, it's the standard deviation divided by the mean. So to get to the mean and the standard deviation, there's two things that you can do. You can use the formula pages that is in your study guides, or you can use the formulas that are in Excel. So the mean, and let's see, I just want to see, so that wasn't calculated via Excel, so it was just the sum divided by 5, but we could have just said the average of those 5 numbers, 1, 2, 3, 4, 5 numbers, and that would have given us 107.4. So that's the mean. So look at the first one. So again, when you look at these things, sometimes again in the exam, you now see 107.4 and you're like, oh, got it. But there's still a few other things that we need to calculate as well. Okay, then we need to calculate the standard deviation. So these formulas that are here are basically the formulas that is in your textbook. So it takes the mean and the sum of the mean and the square root of that into account. But you can also use, again, the Excel standard deviation. So for this one, they tell us it's a sample. So we just use the sample standard deviation. The other one is population. So if they tell us it's a population, we use that one. So just be careful for those two definitions as well. But then standard deviation of that group will give you also. So again, what is in here now for you, and I'll just save it as that, is that you can see, you can use all the the Excel formulas that are in there, or you can use the formula as is given in your textbook. So I will definitely save it as that for you, that you can use both. But then again, if we use the formula of the standard deviation divided by the mean, and we basically make it percentage. So we just need to see, okay, I want us to round it up to 2 or 3. And then we get the answer as option B. Okay, if you did not do it via Excel, so what you then need to do is like we did up here, is you first need to work out your mean. Then you need to work out your x minus mean to the power of 2, so that you can get the sum of all the squares, so that you can work out your standard deviation. So that's again why just sometimes easier to use some of the Excel formulas instead of that. Else, I would suggest also look at calculators but again, it becomes expensive, but calculators that also have a function to work out your mean, standard deviation, and things like that. Okay, so that is the coefficient of variation. And again, you would have seen there was the mean answer, there was the standard deviation. Probably if you did the standard deviation of a population, you will probably have gotten a 3.4. But your final answer is B. And again, just to save time, I used Excel as well for this. There is no easy way to do this else, unless they give you some of these information, like they did in these questions, where they gave you a bit of information. So if I did it in this one, then it might be easier. So also be on the lookout. If they give you that information, they might give you information that is set up for the population standard deviation or something like that. So just be careful around that when they give information, that it is the right information that you can use. Okay. So the next one, and here they talk about. So we'll get into the box and whisker questions now, but basically what we talk about is the 5-number summary. So the 5-number summary is, so if we have that we've got these 5 points. So and that is also there. So, but just to see it in the diagram as well. So your minimum value, Q1, Q2, Q3, and your maximum. Okay, so if you look at this 5 set of 5 things that they give us, maximum is correct. We want which one of the following is not. First quartile is correct, that's Q1. Third is correct, that's Q3. Minimum is correct. The one that is wrong is the coefficient of variation. But here we've also I've added the 5-number summary as well. But just as a graph, this is how it looks like. Okay, so again, some definition questions thrown in between the ones to work out. So that automatically then goes into how they present the five number summary box plots. Okay, so for the box plots, and I think that's one of the places where you need to be very careful, and not in this, but how they put the answers, because it's very simple to make a mistake if you want to say, oh, it's box plot A, that you say A is the correct one, but actually A refers to box plot D. So just be very careful with these kinds of answers that you don't get caught out, because it's very easy to make that mistake. Okay, so let's look at the data that they give us. So we've got only 5 points. That's, I don't want it that big, so that is our minimum, 115. That's our maximum, 150. So what I normally do is I look at the data. So 100, 120, so somewhere here is probably 110. Then in between those is probably 115. Okay, so that's my minimum value that we have. Okay, so let's look. Minimum here, 100, so it can't be this one. So A is not an option. Minimum here is 80. Okay, so B is not an option. Minimum with this one, 100. Remember, it's 150, 15, so C is not an option. D minimum, that's probably around 75, not an option. Okay, let's see. Looks like that can be 115, so might be an option. Then F, again, minimum, definitely under 100, so not an option. So then one can see the only possible one that we deal with is option or box plot E. So box plot E, and it's not that one, so box plot E then gives you that it needs to be option C. So without nearly working out anything, I just eliminated a lot of a box plots to get to that one. But let's look at this one. So the minimum is also equal to Q1. So that's why there's a line with a minimum. Q2 is in the middle. So there you have Q2, and it is, if you cross it, it is around 120. Then that one is Q3, 125, and the maximum is 150. And if you look, it would probably be in the middle of those two. Okay, so that is also just why box plot E was the correct one. So that is how I would nearly do it in the exam as well, is when you look what's your minimum. Then if you have two that are similar, then first look at between those two, then what's the maximum. Um, so before you go into Q1, Q2, and Q3, because then probably you will already have eliminated most of them. It might be that I have another one. Yes. So again, another set of data, minimum 100, maximum 140. So let's go through them. Minimum 100 might be an option. Minimum 80, not an option. Minimum 100 might be an option. Minimum, oh, that looks like 75 or something, not the option. Minimum uh, um, could be 110 or something like that, but we're looking for 100, so that is also not an option. Minimum of 100, that's definitely smaller. Okay, so now we sit with two options that we need to look at. Okay, so let's look at the maximum value. Maximum 140. Okay, maximum looks like 140 there. Maximum looks like 140 there. So at the moment, still nothing that distinguished between them. Okay, so let's look at the next one. Okay, so let's just so Q1 110. I look at that and I look at that, it seems like both are at 110. So Q1 is also right. Q2 is your median as well. That will be, so that seems correct. That also seems correct. So nothing wrong yet. Okay, so what is your Q3? Okay, so your Q3 is it 120 or is it between those two? Okay, so your Q3 is 120. So that's why this one, even though it seems so different, look at that gap between those two. So we would have expected that it's 100, 110, 120, 130, 140. Then it would have been this one. But what this now tells us is that 140 is a bit of an outlier. And that is why option C is the correct one and not option A. Okay, so here we can also see the person that sent it to me said that one, but it was incorrect. So just remember here that Q3 is exactly that number. So it is 120. So this is a very weird one where your Q2 and your Q3 is exactly the same number. And Lynn, before we get to your question, if your number set was 100, 120, 120, 120, 140, what would have happened then is you would have had that bar, you would have had the bar like that, and you would have had, and then that would have been connected because those two are then not outliers because both are 20 away. So that would have been your 100, that would have been your 140, that would have been your 120, where Q1, Q2, and Q3 lie. So it would have just been one line. Okay, Lynn, you had a question.
Thanks, John. Just as a refresher, the definition of outlier again was that when it doesn't touch the actual box itself, or it sits outside of those
It it
bottom
sits
lines. Mm.
outside of, so it's basically not, and I'll
Okay.
make a, let me just make a note and
Yeah.
get the formula for outlier for you,
Yeah.
because there is a formula that you can, that one can use to get to it. It is something like one or two standard deviations from the mean or something like that. But I'll get that formula for you guys that you can use it.
Okay, they'll always be depicted as dots that don't touch the rest of the box plot.
Yes,
Okay, cool.
yes, yes.
Cool.
It will always be. Let's quickly see in this one. See, so that would have been also indicating an outlier. That that one that was also 140. So this looks very similar actually. So all that they probably changed is the data. And that is what will happen in, I think it happened in your assignments as well, but that will be what's happening in your exam. You will probably get the same type of box plots, just with a different set of data. Um, yeah, but I get the outlier formula so that one can just add that you can just use that specifically for these kind of questions.
Cool. Thanks.
Oh, okay. So did I just want to quickly check? Okay, before we go into the probabilities, I just want to move these two into there because that needs to be part of. Um, so it what I've seen, and I just want to see if there's another one. Um, is that in a lot of the assignments, they sometimes don't have a stem and leaf um, type of graph, and then suddenly in the exam there's one, and because it was never asked in any of the assignments, then suddenly you stuck with it. So that's why I just added the stem and leaf in, and we'll cover two on that. So again, stem and leaf is just a visual representation of data. Um, what they can ask you around the stem and leaf is very similar to if you have a table of data or anything like that. So they can ask you what's the minimum value, they can ask you what's the maximum, they can ask around the range, they can ask median, mean, and what they also like to ask is the same that we had in some of these questions, the position of. So I think that is just important that we make sure that we cover all of that. So let's quickly look what we're asking, and we're asking the incorrect one. So the range is always the maximum. So that is 86. minus the minimum, that is 35, 36. So that is 50. So the range is correct. The fifth largest number. Okay, so remember, small starts here, large start here. So the fifth largest, 1, 2, 3, 4, 5. The fifth largest number is 80. Okay, we're looking for the incorrect one. So that is incorrect. If it was the fifth smallest, 1, 2, 3, 4, 5, it would have been 50. Okay, and then you would have said it's correct. So again, just be very careful what how they use it, because if you count it from the bottom, you would have said it's 50, but the largest count from the end of the stem and leaf. Okay, let's just look at the others. We have 53 numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 17, 18, 19, 20, 21, 22, 3, 4, 5, 6, 7, 8, 9, 10, 31, 32, 33. So that is correct. Let's look for the mode. So there's a 51 that happens twice. There's a 55 that happens twice. There's a 64 that happens twice. There's a 70 that happens 3 times. Okay, so the mode is 70 because that is the number that happened the most. You can have more than one mode. So if 64 also had a third number, 64 could have been the mode as well. But in this instance, only one mode, and that is 70. Then the median, how to work out the median. So we have 33 numbers. So basically 16 to one side, 16 to the other side gives you 52. So the one in the middle will give us the mean. We can also do that. The median, sorry, is to say 33 plus 1 divided by 2. That is the position. So the position is position 17, and that must give us the median. So let's count 17. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So 17 was 64. Okay, so that is correct. Remember, median is also Q2, and the Q2 formula can also be written as divided by 4. So then you would have seen, if I do 2 divided by 4, there's your n plus 1 divided by 2 that I used there. Okay. So normally they do ask a stem and leaf in your exam, so just be wary of that. We've got another one. So look at that, exactly the same data. 36, the smallest, 86, the largest. So exactly the same data. Here they ask you again which one is incorrect. And now look at what they give us. The range is 50, so we know that is 86 minus 36, which is 50. So this again is what will probably happen in your exams with the different types of questions or different papers that everybody is writing. So now they actually ask for the fifth smallest. And then fifth smallest is 50. So that one is also correct. There are 53 numbers. So again, if we count it, that will also be correct. The mode is 70. Again, it's the same data set as the previous one. So that is correct. The median is 4. Okay, so we've worked out that the median was that one. So very easily, one can make the mistake to say, okay, it was that number, so it must be 4. And then you forget about, it is actually 64 and not 4. Okay, so the same set of data, very similar types of questions. Just now, one of the others is the incorrect one. So just be very careful, and that is again in the exam. How it will be is that the questions will be different for for you guys for the different types of papers that you write. But again, it is not that the whole question set will be different, like you would have seen in your assignments as well. It's they can just maybe give you a different set of options, or they ask you a different type of question. Okay, so that again is just to show you the stem and leaf, so that we know we've covered that as well. Okay, before we go on, any questions up until now? Okay, cool. Next one. Okay, so now we go into probability, that is study unit 4. Okay, probability, they can ask you in a few ways. They can give you a table. They can give to you in a different format where they give you probability of A is this, probability of B is something different. So again, just be on the lookout for the different ways that they can ask you probability. So let's see what they give us. Distance from home to school for 800. So we know the total is 800 primary and high school learners. Okay, so we probably need to add a few, because there's also a gap there that needs to be filled. But let's look at what they ask us. Events, high school and less than 3 kilometers are not independent. We are looking for the incorrect one. So events, high school and less than 3 kilometers, that one. So we're asking about, sorry, high school and less than are not independent. Not independent means dependent. Okay, so how do we know when it is dependent or not? Now we go back to way early in the year. Okay, so when something is dependent or not, we need to work out with a certain formula. Can you guys remember what that is? Okay, so when something is dependent or when something is rather, let's check when something is independent. When independent, I hope I'm writing that right. So when something is independent, the probability of A and B is equal to the probability of A times the probability of B. Okay. So that is when something is independent. So if we get that those two are not the same, then we say it is dependent. Okay, so let's look at probability of A. Phew, okay, so now we need to get the total of high school. So we need to add all of those together. So let's see, that is 48 plus 112 plus 160. So that is 320. So the probability of high school would have been, and let's say high school, would have been 320 divided by 800. Okay, so that's the probability that one of the students is in high school. 320 divided by 800, and we will need to multiply that answer by what is the probability less than 3 kilometers, less than 3 kilometers, less than 3 kilometers. Okay, so now we also need to work out each of these to see what is that gap. So we know then if that is 800, that is 320, that the probability that somebody is in school or primary school is 800 minus 320, which gives us 480. So then we can say 480 minus 240 minus 168. That gives us the primary school that is less than 3 kilometers, but we want the total of that. Sure, this is a long question. So 72 plus 48 is 120. So then we need to say 120 divided by 800. Okay, so 320 divided by 800. See, this takes a lot of time. 0.4 times 120 divided by 800, 0.15. So that is 0.06. The probability of A and B is those two where that meet. So that is 48 divided by 800. 48 divided by 800 is also 0.06. Okay. So those two are the same. So if those two are the same, we say it should be independent. Okay. So the events high school and less than are not independent. So that one is incorrect because it is actually independent. Yo, okay, I hate these terminology. They could just have said dependent. Um, we're looking for the incorrect one, so A was the incorrect one. Okay, let's just see, go through the other ones. The student that sent me this last year, he said the probability that a random chosen learner is in high school, 0.4. We just did the high school, was 0.4, so that was actually correct. Event primary school and high school mutually exclusive. Okay, so yes, it is mutually exclusive. Mutually exclusive means that you can't be in both. So you can't be in high school and in primary school at the same time. Um, so that is correct. The same, we could have said less than 3 kilometers, between 3 and 6, and greater than 6 is also mutually exclusive, because you can't be less than 3 kilometers from school and then suddenly you're between 3 and 6 and then you're more than 6. You can only be in one of them, so that would mean that it is mutually exclusive. So let's might have now answered that one. Events less than 3 kilometers between 3 and 6 and greater than 6 are complementary. Yes, it is. Remember, complementary, what we've normally done is just one complementary. So we would have said if probability of A is equal to 0.6, the complementary of A, and there's a few ways that we can write it. It can be that, can be written as BA with a dash. The complementary would have been 1 minus 0.6, which would have given us 0.4. This is just an example. It doesn't reflect with those. So we would normally only have had 2 that we looked at. Here, basically, all 3 of them are complementary. So if it's not less than 3, it must be one of the other 2. So that is correct. And then the probability that a random chosen learner is in high school and travels less than 3 kilometers from home to high school. Okay, probability that the learner is high school. Okay. And travel less than 3 kilometers. So it's basically that one that we have calculated, which was the 0.06. So it was the 48, because it's a probability that the random chosen learner is high school and travels less is 48. And we divide it by the total 800, which was what we calculated there. Okay, so this one was a lot of detail, and luckily the first one was the incorrect one, so you could easily not do the rest, but to get to that one was quite a job to do as well, and it takes time. So when you get to the probability portion, it might be that one try to look at answering the simpler questions first, and then when you sit with the rest, so it might have been easier to calculate just that probability, that one to look at, that one to look at, and that probability before we've calculated that. So one nearly needs to in the exam, also look at what you're most comfortable with in working out, and it might have been much shorter time to say, okay, let's look at the other options before we try to work out if something is dependent or not. Okay, so now you see exactly the same data. They tell us the total is 800, so now it's completed and filled in. Calculate the probability that a randomly chosen learner is either in primary school or travels more than 6 kilometers from high school. So this is quite the interesting one. So it's primary school. So primary, I'm gonna just quickly go back. So that was for 80. That was 320. Okay, so choose learner is either primary school, so that is 480 divided by 800, or the learner is also travels less than travels more than 6 kilometers from school. Okay, so that is those two added together, which is 400 divided by 800. So it's looking at that one, and it's looking at that one. Okay, so 400 divided by 800 is 0.5. 480 divided by 800, or 80 divided by 800 is 0.6. Okay, so if we add those together, we get 1.1, not the option. So what am I missing? Okay, so what we are counting in both of these two is that 240. So we're counting it in the primary school part, and we're counting it into the greater than 600 or 6 kilometers from school. And that we're not allowed to do. So we still need to subtract one of those 240s from the equation. Okay, luckily 1.1 wasn't in one of the answers, because then one could have made the easy mistake. So we still need to subtract the and that was in both. So 1.1 minus 0.3 is 0.8, which then is option B. Okay, so and that's why, again, for me, it's easier when I look at this and I draw and write, because now it's easier to see, okay, those were the three that I counted or summed to get the 480. Those were the two that I summed to get the 400. In both of them, there were 240. So I'm actually double counting the 240. So I must subtract the 240 from my probability equation. So remember that. And it's quite interesting that there wasn't an option of 1.1. Yes, Lynn.
Thanks, John. Just a quick one. So, in terms of the formula for this, when dealing with the or, is it probability of A plus B minus the probability of
A and B. So,
A and B.
yeah, so it's the probability of A plus the probability of B minus the probability of A and B.
And B. Okay, cool. Thank you.
Perfect. Okay, so, and that's why originally also, so sometimes they can ask you just the probability, and that might be in how they'll do it between the different papers, is if I can say calculate the probability that a random chosen learner is in primary school and travels, so that you then just look at the and. So it could be that is how they change it in the exam, or they say less than 3 kilometers for primary school or something like that. Okay. So let's see what is. Oh, okay. I should have moved that one also in there. So, but let's also look at this one. The following stem and leaf represented by the table below. Range 52. So let's just see. We're looking for incorrect one. So 73 is the maximum. Minus 41. So the range is 32. So that is correct. The mode is 65 and 66. And I think, Lynn, you asked that last time, can it be 2 modes? So let's check. Okay, the first mode is 52. Because there's 2 of that. 65, there's 2. 66, there's 2. So the mode is actually 52, 65, and 66. Okay, so that is the incorrect one because there's actually 3 modes. So again, yes, vote to all the modes, but there is a third one that's also a mode. So this, I don't even know what you call it. If it was 2 modes, it would have been bimodal. Could this be trimodal or multimodal or something like that? I don't know, but this basically can happen in the exam, that you're so fixated that you see, okay, there's 2 of them, so it is the mode, but there is another one there as well that has happened twice. Okay, 5th largest number. So remember, largest that we go from the maximum side. It's 1, 2, 3, 4, 5. So it is 66. 17 cars. So to get the median, 17 plus 1 divided by 2. So that is 18 divided by 2. So position number 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Position number 9. 61 is correct. The mean is the measure that is affected by the outlier. Okay, so if you look at, if that number was not 73 by 94, the median would have stayed the same. It would have been your 9th number. Your mode would have stayed the same. Okay, so the only measure that would have been impacted by an outlier is your mean. Okay, so that is also correct. So they can ask that in a definition question to you as well. So the mean is the only measurement from the dispersion one that is influenced by the outlier. Okay, so if there was a different number you can see that your median would have stayed the same, your mode would have stayed the same, but the impact would have been on your mean. Okay. Okay, so that should have been also, sorry, I thought there was more, but that should have been also here. So what they now did, and this is very weird. So they've given you 5 data points, and they've written to you or asked the question to give that as a stem and leaf. They also give you a hint. Okay, so they tell you round up 19 or 18.5 and 30.5. Okay, so the numbers is actually 19 and 31. I don't know why they just didn't do that. Okay, so then if we put it into a stem and leaf, so let's just see what options. So we're not going to have, the smallest number is 19. So this number is 109. So you can't have anything with a 10 or 30. So this one is not correct. You see the smallest is 19, the highest is 31. So you can't have one with 2, so that one is also incorrect. They told us that we need to round up, so you can't have those in there, so that is also incorrect. You can't have a 19, a 20, and then these two numbers, so it doesn't again make sense. So basically that is the only one that is correct. So even without looking at it further, but let's look at the smallest number is 19. The biggest number was 31. And then we have a few numbers in between. It was 20, 22, and 25. Okay, so which is that one. So why they didn't just give you 19 and 51, I don't know. Would have just made it easier than to round it up already, but then they probably wouldn't have been able to give you some of those options. Okay, so a different way to look at the stem and leaf and to position it a bit differently. Okay, so it's already 3:30. So let's stop there for today. We can continue next week. What I will do for next week as well, I'll make it longer. I'll make it an hour and a half so that we can just get through the work quicker. But I'll plan it according to load shedding schedules again. Um, so if I don't know yet what the load shedding will be next Saturday. So it might be anything between 8 and this time nearly that I will schedule it, but I'll schedule it around those schedules because I don't think load shedding will be over by